Buenas tardes, todos. Good afternoon, everybody. My name is Fabrice and I am a member of the Scientific Advisory Committee on Climate Change of the Chilean government, also called C4. It is my great pleasure to greet you all at this International Seminar, Climate Change in Latin America and the Caribbean. It's organized by C4 and the Chilean Ministry of Science, Technology, Knowledge, and Innovation. Before we begin, please ensure your mobile phones are on silence. I would like to particularly greet Mr. Fernando Lopez Hernandez, Head of the Division of Climate Change at the Ministry of the Environment. Thank you for being with us today. Now, welcoming our speakers is Dr. Camila Fernandez. She's Director of COPAS Coastal at the University of Concepción. She's a researcher at the French Centre National de Recherche Scientifique. And she's co-president of Chile's Climate Change Scientific Advisory Committee. Dr. Fernandez is a marine biogeochemist whose research focuses on climate change and nutrient cycles, and she has played a leading role in strengthening ocean climate science in Chile and internationally. Please, Dr. Fernandez.
And smaller than thank you so much. Good afternoon, everyone. It is a privilege and an honor for Universidad de Concepción in Santiago to welcome you all to this very important meeting. It is quite the occasion because for once it is birthday, so let's celebrate that first. Then Chile is welcoming 230 scientists from all over the world, 60 cities in all, to a very important task. They are initiating and consolidating the 7th cycle of the IPCC, and this is critical for us all, actually. But most importantly, for countries like Chile, where the scientific community is not only active, but it is engaged in every aspect of the world, in research, in public policies, and trying to make a difference. It's very inspiring for us to welcome you, and it's very inspiring for the Scientific Council of Climate Change, which, along with Sandra Cortez, our president, I co-preside, to be part of this process, at this small side of it. Other than communicating and exchanging experiences and scientific information, we want to engage the future generation of scientists and the future members of this scientific council. They will play a leading role, a key role in what is to come for countries like our own. So meetings like this, they are a privilege. I want to thank the University of Concepcion for organizing and welcoming us all to this in this lovely venue. Thank you all for being here today to participate. And thank you very much to our speakers. It is really an honor to have you here with us. Thank you to Mr. Ladislao Changa, Vice Chair of the IPCC, for being here today as well. And thank you, our Chief Division of Climate Change from the Ministry of the Environment, and for being here today. Yeah. So I will give you the floor now to have a few words, and let's kick off this very, very exciting meeting. So thank you.
Thank you, Dr. Fernandez. Our next speaker is joining from the welcome, Mr. Hernan Lopez Hernandez. He's head of the Climate Change Division of the Chilean Ministry of the Environment, an electrical engineer from the Pontificia Universidad Católica de Chile with a master's degree in energy and nuclear engineering from the Politecnico di Torino. He has worked extensively on climate action in Latin America, including mitigation, adaptation, energy transition, and climate finance. Please.
Great. Well, good afternoon to everyone, distinguished authorities, esteemed experts, academics, and participants. It is an honor to welcome you into this important meeting in Chile. I would like to begin by sincerely thanking you for your presence and commitment, especially highlighting the significance of having the Intergovernamental Panel on Climate Change in our country. This event marks a significant milestone. It is the first time that the IPCC has organized a meeting of this magnitude in Chile. This not only fills us with pride, but also places the country on the global map of climate change research and action. Chile has demonstrated a strong commitment in this area. The approval in 2022 of the Framework Law on Climate Change represents a decisive step towards sustainability, adaptation, and mitigation. This law mandates that public policies be based on the best available scientific evidence and establishes a scientific committee to advise the development of climate change policies. It is important to emphasize that this legislation is the result of a state policy, enabling steady and cross-cutting progress across all sectors of society. IPCC reports are fundamentals. They provide a solid foundation for the development of effective climate policies and play a key role in multilateral negotiations, such as the United Nations Framework Convention on Climate Change. Through them, science becomes a concrete tool for decision making. The work of the IPCC represents the voice of scientific knowledge in the public arena. Each report ensure that evidence-informed policymaking, which is essential for advancing effective global climate action. I would like to invite all participants to take advantage of this opportunity to engage in a fruitful dialogue, share ideas, and connect local experiences with global knowledge. Finally, let us remember that we share a common horizon, the urgent need to address climate change for the well-being of present and future generations. Thank you very much.
Thank you very much for this inspiring words, Mr. Lopez. Now we will move to the first presentation. It is an honor to welcome Dr. Robert Roda, co-chair of the IPCC Working Group 1 for the 7th assessment research. Dr. Roda is a senior climate scientist at the French National Center for Scientific Research and at the Institut Pierre Simon Laplace, where he participates in Europe's major climate research efforts. He also contributed to the IPCC report since the 5th assessment report. And joining him will be Professor Xiaoyue Zhang, co-chair of IPCC Working Group 1. Professor Zhang is a meteorologist graduated from Nanjing University. He's an academician of the Chinese Academy of Engineering, the director of the Greenhouse Gas and Carbon Neutrality and Evaluation Center of the Chinese Meteorological Administration. He's also the director of State Key Laboratory of Disaster Weather Science and Technology. He has contributed to IPCC reports since the fourth assessment. Please.
Thank you very much. It's really a pleasure and an honor to be here and share a few things about this institution, which is now more than, I think, 35 years old, more than that, I think, this year. So it's really an honor also to be invited by this scientific committee, the government, and to meet you. And we, of course, are here to answer your questions as far as we can. The science is moving very, very fast also on our side. So we are not fully aware about the recent developments. But let me start maybe by... Sure. Yes, 6 years. 6 years we are waiting to be in Santiago. Why? Because in 2020, the last author meeting of the previous cycle was supposed to be here in Santiago. Yeah. And we were really expecting it. We were really waiting for it, but it was not possible in the end because of COVID and consequences of COVID. So we are really happy to be here today and to be with you. It was really not possible to go elsewhere. So yes, I will say a few words about our institution, Intergovernmental Panel on Climate Change. Sorry for the typo. It's really the mandate of IPCC is really to provide policymakers with regular assessments of the scientific basis of climate change for its impacts and future risks and options for adaptation and mitigation. So the reason why we are here is really to inform not on the latest research, but to inform of the knowledge. So very different. Knowledge is kind of the stuff and what we know, what is robust at finding, and if not robust, we have to assess that. That's our mandate. When we have several studies, many studies going in the same direction, we can make very strong faith. If it's only one study, it can be a very good study, but we have to wait a little bit to be confirmed by other lines of evidence, other types of data. So the robustness of those findings and this knowledge serve actually policymakers, and they have served policymakers now for a number of years and cycles. And there were decisions, as you can see, each report actually was leading to very important decisions. If I can just mention a few, the fifth assessment report came before the Paris Agreement. And the Paris Agreement was really based on the findings. And the sixth assessment report was was ahead of the first global stocktake, COP28. So it's really important. So now we are heading to a period of we will have the first report will be a special report on climate change on cities. It will be delivered in 2027, next year in March, probably. And then the other reports have no yet agreed timeline, but they should be delivered somewhere between beginning of 2028 and the middle of 2029. We don't know exactly. There are still debates on the dates of agreement of approvals. So one very important. Why do we have this success and robustness? It is because essentially IPCC is based on a consensus principle. Consensus among scientists, and you can see the picture here that we made in Paris when we started the cycle with all the working groups and some of our teams, who made a very nice picture here. And all these teams, all these group of teams, have to agree on the findings and the level of confidence we have in the findings. It's not only the findings, it's the level of confidence. That's what is important. And second, we have to have agreement between scientists and governments. So that is the other part, the other side of the work. And here are a few sequences that were occurring in Anjou last year when we were agreeing between the governments and the scientists on the outline of the reports. So these were kind of sequences. You can see our fabulous members of the Bureau, some of which are here. Sonia, Ines, Shirley, Edwin, Maheswar. Am I missing someone? Yeah, some of our vice chairs are not here today. So some heavy discussions on how we can change a bit our outline to be okay with the governments on the low left side. Sometimes there is not agreement and we need to discuss. So we go in the corner of the room and we make what we call a huddle. And you see this one was to discuss the title of chapter 8. And there was, in the end, an agreement on this chapter. And the gavel, at the end, when everything is agreed, makes the start of the report. And of course, we are so thankful to our technical support units. We have colleagues in Paris and in Beijing helping us. Some of them are here, helping us to do everything we are doing, including this session. The meeting, the whole meeting. So where we are at the moment, the making of a report takes several steps. It's long. It's long because we have to have agreement of all the bodies. So in the first steps, we have a scoping with experts. We have the approval of the outline with the panel. We have to nominate. We have the nomination of authors. That's on the government side and observers. The Bureau makes a selection of the authors, and then we start working with the authors. And that step takes about 1.5 years already. So here we are we are at the moment in the process of writing the first order draft. It will be available for review, for expert review in August for working group 1 and later for the other working groups. So it takes a few months. And then we have a review. We take stock of all the comments. We have to consider all comments, answer all of them. And then we have a second draft and a final draft. The second draft involves government. So maybe I just continue with this. The final stages are the variance review, and at the end, there is an approval of the summary for policymaker, which makes an approval of the overall report. We expect that for working group 1 to be about in 2028, mid 2028. Next, just a few highlights of the previous cycle. So this is not new. This is basically, the trajectory of these observations and the trajectory of the models, taking into account the greenhouse gas emissions, and the same trajectory of the models without taking into account the greenhouse gas, the greenhouse gas emissions. So there is a clear difference, which leads to say that the warming is now essential. Is now completely due to human activities. So we can go in detail, but I won't bother you with this. Now, as you know, sometimes we are asked, "Oh, have we predicted what is currently going on? The observations, the temperature going?" Of course, it's been more than 30 years that we have predicted that. This figure shows the observations. This curve, which is a little bit variable, the projections that were made at different times. It's completely consistent. I mean, we have been predicting that for decades now. So and I'm not expecting much new results regarding the influence of human activities on climate. So it's been a long time that we have predicted what is currently happening. So one of the other results, and you will see that these maps are actually we have symbolic hexagons, which are nice and nicely adopted now. It's good for approval because there's no detail of the country boundaries. So that is much easier to get approved. And these hexagons are actually showing regions of the earth, here land regions. And what we see, for instance, is that almost for all regions we have high confidence that at all the heat waves that we are experiencing and the increase in frequency of heat wave is due to human activities. There is no doubt on that. There is a little bit of a gray zone here, which is not, which doesn't say that there is no change. There are more heat waves probably in this area, but we don't have enough data. So there are some areas for which we are missing data. For agriculture and ecological droughts, we also have some increases, very significant in West America, West North America, and Mediterranean regions. And for other regions, the signals are less, or at least were less prominent in the last cycle, and were not fully attributed or attributed only with low confidence. And we expect those maps to evolve with the 7th. And my colleague Sonia will talk about it also in the next presentation. For heavy precipitation, we also have a number of regions for which we have high confidence that they are increasing and doing a lot of damage. And this affects actually more than 3 billion people who are in an extremely vulnerable context of climate change. So I'm not going to unveil what also my other colleague Ines will present, I'm not sure you will present in Spanish or in English. In Spanish, great. That would be fantastic. But just to say that Central and South America is also experiencing a lot of consequences on the physical side. We can see that, for instance, a number of regions, when you have this brown circle, it means that it will be increasing in the future, and it's showing that, of course, temperature increases everywhere, but sea level will cause a problem everywhere. Heavy rains sorry, that's rainfall with changes on both sides. In many sub-regions, and also fire weather. So there will be a lot of things that will happen in the future. With this, I will give the floor to my colleague, Xiaoye, to continue on AR7. So that was really AR6. Now, AR7 is in your hands. Okay.
Okay, thank you, Well, my fellow co-chair of the Working Group 1, the 7th assessment cycle of the IPCC. So it's my pleasure, and we are here and to talk something, and we can exchange the things we're doing. Like Hobel has already mentioned, we are now moving toward first order draft. That one is depending on the approval outline. This is our working group outline. So you see that we have a 10 chapter. 1, 2, 3, 4 is we call in the past and the current segment. So the chapter 2 is just a large scale changes in climate system, not just the climate. It's an earth system change, including the atmosphere and another sphere, and also including the human activity, but in the global scale. And chapter 3 is changing the regional climate and the extreme. We would like to assess the publication, especially during the past 7 or 8 years, and we move from the global scale and to the regional scale. And chapter 4 is for the processes, and it's just can tell the people what's a new understanding of processes, and this kind of understanding can explain the observed climate change globally and regionally. And then we move to the future, and the decision maker, and also the scientific community, and also the public want to know the future. So from the chapter 5, we have a scenario. We're focusing on the scenario. Scenario is combine nature, climate science, and with the social economy science together. They just use some consumption and to make some consumption in the future, anthropogenic CO2 emission, and how the pathway will go to reach the peak and then reduce and something, and how the society can afford, use what kind of the technology, and how the social economy change. So this scenario is just is a very, very fundamental tool, and we can use the versus model, rely on this scenario. Maybe they have a very high emission, very low emission, some plausible future emission,
and we can get a global projection of the future climate change, future warming level. And this is in the chapter 6. And in the chapter 7, we also go to the future from global to regional. And we will tell the regional climate change, including the extreme. But not stop here. And in the chapter 8, we will focusing on some high impact event, and some we call the tipping system. That system, if you cross the tipping point, maybe something is irreversible, and this kind of the information is really important, and decision maker want to know. This is highly related adaptation. If we try to put some money, and they want to know how the things and will occur. And ninth chapter, and we will focusing on if we face so many challenges, and do we have a way to stabilize the temperature, and how the Earth system responds to the stabilize. And this is kind of the things, for example, we can directly capture the CO2 and storage, and also we can use solar radiation modification method, and use all kind of the method, the way we try to stabilize the temperature. And then we have on the basis of all this kind of information, and we can go to the climate information services, and this is one of the side of okay. So this is the our it's just a general outline, and we about 200 some scientists work together, and we try to have all this kind of information provided. And I also would like to highlight something, some critical scientific progress in the AR7. In the chapter 2 and 3, we would like to provide improved understanding of the recent global and regional climate anomalies. You know, the climate change, and we just pay attention to the 10 years average. We just make a comparison with this, and we see the changes, and also focusing on the extreme. Chapter 4, and we will integrate it advanced in climate system processes and water cycle, and also carbon cycle, and also the biogeochemical cycle, all this kind of information. From the chapter 5 to 7, and we will have a new projection using even in the regional scale, we're using the kilo scale modeling, and also associated with the AI, and with a very complex Earth system model, and also simple Earth system model called the emulator. Yeah. And also for the two parallel chapter 3 and 7, we will install a full range of assessment, and including the three you're in the South Latin area, past, current, and future. Chapter 10 focusing on the regional climate services and capacity building. This is a tangible chapter, and we will have a lot of information to the working group 2 for the adaptation impact working group, and also some information to the social economy, fuel is mainly just coming from the wood industry. To conclude, you see, we are just in the glacial, and our scientific can just go into the very rare people area, and we just will provide advanced scientific understanding. So the IPCC just try to make it clear the choice and action implemented in this decade will have an impact now and for the thousands of. So the certain cycle will build on this to deliver the science the world needed for question. And we would like to take a question after all the presentation. Okay. And thank you for your attention.
Thank you very much, Dr. Oda and Dr. Zhang, for this very nice overview of the IPCC work. For our next presentation, it's a pleasure to introduce Professor Sonia Seminario, Vice Chair of IPCC Working Group 1 and Professor of Land Climate Dynamics at ETH Zurich. Her research focuses on climate extremes, droughts, heat waves, land climate interactions, and terrestrial water processes. And she has been a coordinating lead author in several major IPCC assessments, including the special report on 1.5 degrees and the sixth assessment. Please welcome Dr. Seminario.
Yeah, thank you very much for the introduction. It's also a great pleasure and honor for me to speak here. Tal vez puede ser decir que hablo un poco el español, entonces o castellano, pueden también hacer preguntas en castellano, pero but my English is better. So in English. So let's speak about the climate crisis and climate change and give a global picture on changes in climate extremes. We are in a climate crisis. I think that's the word we need to use. And the situation is worsening every year. You see here a picture of the temperature in each single year. So that was the average warming in each single year. And you see that the 2025, so last year, was the third warmest year on record after 2024 and 2023. In 24, we had for the first time a temperature which was above 1.5 degrees. So you know, of course, that in the context of the Paris Agreement, there was an aim that was set by many countries of the world to limit global warming to 1.5 degrees. A single year doesn't mean that we have a long-term average yet of 1.5, but we expect to reach 1.5 degrees, a long-term average in about 29 or 2030. Here you see another figure also from the Copernicus service, which is also very striking because you see here for each distribution, for each single years, it shows for any single day of those years, what was the anomaly compared to the average in 1991 and to 2020. And so you see the last PDF, so the last distribution for 2025, all of the data is actually above zero. So it means each single day was actually warmer than this average. And I think this the illustration shows very clearly how extreme the conditions are that we have at the moment. And you see also how strongly the warming is now being amplified in recent years. So again, there is also this global picture, but there are also single events in different regions, including in Chile. So for instance, in Chile, in January of this year, there was massive fires that took place, probably you remember them. They led to about 19 deaths. There was 1,500 people which were left homeless, and 50,000 people were evacuated. A study from the World Weather Attribution Group showed that this event was made more probable because of human-induced climate change. And it's also the case of all those events shown on this slide, and there will be many more. For instance, the fires in Los Angeles in 2025, the costs were $135 billion. there were about 18,000 structures destroyed, more than 30 deaths, and about 200,000 people evacuated. In Canada, 2023, there were also massive fires. The total burnt area was equivalent to 12 times the total area of Santiago, the Santiago metropolitan regions. And the CO2 emissions associated with that were equivalent to 3 times the emissions that you normally have every year in Canada. So this shows also the potential for amplification of the climate crisis, because this fire was a result of the increased temperature and drier air, but as a consequence, we had these fires which led to even more CO2 emissions. And some other events show also that it's not only about fires, but also, for instance, heavy precipitation. So in Valencia, in Spain, 2024, probably you have seen those pictures. There was massive flooding that was resulting from very intense precipitation. The total rain that fell in one day was equivalent to the rain that normally falls in 1 year. The total cost were 11 million damage, and 232 deaths. And you see here what happens in the streets of the city. And then you see also in 2022, in Europe, we have a very extreme drought and heat wave. It was the driest summer in 500 years, and there was a record burnt forest area. In addition, often we have droughts and heat wave in the same years, because when you have a drought, it amplifies the heat. So there were very extreme temperatures, and there were about 61,000 deaths from this heat wave. So as we see, there are very strong consequences of climate change already now. Already now, there are people dying of the consequences of human-induced climate change. And here I'm going to just summarize the main findings we had on climate extremes in ER6, but I will also present some new research on this topic. So in ER6, the main conclusions we had was that the evidence on changing climate extremes has strengthened. So basically, in recent years, we have much more evidence that extreme events are becoming more frequent and more intense. We could also say that human-induced climate change is already affecting many weather and climate extremes in every region across the globe. And another really important point is we are starting to see events that are so extreme that we can say that it could not have happened without our influence. So we are starting to see events of which it's very clear, without emissions from humans, it would actually never have been so extreme. This is a picture that Robert has also shown, and this is what we had in summary for policymakers. As mentioned, we do see that many regions, every region is affected in some ways. There were also more extreme events considered. One question that remains, and that also came in the presentation for Robert, is do we have an increase in heat wave in South and South America? I mean, clearly there is an increase in the southwestern South America. And we have actually new evidence on this, so we can complete this map. So the next picture, this is actually from a paper on preparation. We are preparing with several colleagues, and based on 2 new studies, so a study from Rusticucci and Zazoulier from 21, and also another study from Seong and Time in Journal of Climate, we know now that there is also evidence of increase in heat wave in the southern parts, so in Patagonia. So you see this map actually shows much more regions with demonstrated increase in hot extremes. And as mentioned, there is further evidence of attribution of events, such as the fire events this year. Here you see what we had already at the time of the AR6, but also completed with these new studies that we had in recent years. So it's also from this study. And it's about what are the projected changes in climate extremes at 1.5 degrees of global warming. And to some extent, we can say it's basically what we expect for the end of the IPCC cycle in about 4 years from now, in 2029. What you see is even much more evidence of increase. And actually for Chile, you see that certainly there is an increase in heat extremes, but we have also evidence of increase in heavy precipitation in the southern part of Chile, and increase in drought also in the southern part of Chile. So now I want to say a few words about the future. We have seen what is evidence from observation for the past. Here for the future, what you see is a figure from the synthesis report from IPCC, and it shows the evolution of global mean temperature. So on the left, up to 2020, you see the evolution of observed global mean temperature with a clear increase. On the right, then you see what are the possible evolution depending on the emission scenario. A very important point is that even the best case, so the very low emission scenarios, we are certainly not going back to the climate of the 19th century. The best case that we have is just that we can stabilize global warming, because every additional CO2 emission means even more impact, more change in the climate system. So the best case is we can stop emissions, zero emission, but then it would just stabilize very slowly. But the worst case that we see at the top with very high emission, we would have much more change in that. And so this would be actually dramatic, as you can see, much, much more increase than what we had before. And what this is illustrating is also the implication for the population. So of course, for young kids born in 2020, that's actually what is at stake. It's their future. The decisions we are taking now are going to influence the climate they are going to live with. So I want to illustrate what this implies. We have seen so far just the global mean temperature, but there are implications for changes in climate extreme. And this is illustrated in this figure. So we are looking at the frequency of hot extremes, so events that would have happened only once every 10 years in a climate without human influence. And in this figure that was from 2021, that's why present 1 degree, but it was a few years back. You see that already a few years back, such an event was happening 3 times every 10 years. So it's already much more frequent, and that's showing that climate change is already happening and having impacts right now. At 1.5 degree, you see, and that's what we expect in 2029, 2030, such an event will happen 4 times every 10 years. So that would be already much more even than just what we had in 2020. That's the best case. But in the worst case, then we would go to 2 degrees of global warming. And that's what you see. Actually, that would be also happening around 2050. And what you see in that case, we had such an event about 6 times every 10 years. And the absolute worst case is basically if we burn all the fossil fuel we have, we burn all the petrol, all the gas, all the oil we have, we could get to 4 degrees of global warming, and such an event would happen then 9 times every 10 years. So we see, obviously, we can still avoid the worst here, but of course, there are already impacts right now. Also for droughts, we see very strong impacts. What I was showing before for heat wave, it was the average changes globally on land. Here it's for drying regions. So we find that some regions are drying, some are less, but not showing strong changes. But as you can see here, Chile is part of those drying regions. So the 2 regions here of Chile, they are included. And we have also increase in droughts, for instance, in the Amazon region, which threatens the rainforest there, so possibly leading to more CO2 emissions, also in North America and Europe. So definitely drought is also a very strong threat, and definitely also here in South America, and definitely in Chile. And it's the same case here. You see with increasing global warming, we have an increasing of the frequency of those events. So a drought that would have happened only once every 10 years without human influence would happen 4 times every 10 years at 4 degrees of global warming. And also the intensity is increasing. So it's also more extreme events, not only more frequent, but more intense events. Here I'm showing some new results that's from our research group from Fulden Batimenis in our group. It's looking at, we were thinking of looking at the different metric, not the frequency of extreme events, but the frequency of normal conditions. Because obviously, with increasing global warming, you have less and less, for instance, months that would be normal. So we were looking at how frequently we would still have months that can be considered normal that would fit in the climate of the early 20th century. And if you look on the right, at 3 degrees of global warming, you see that in most locations of the world, you have only 10 to 20% of the basically the months that would be normal. This means out of 5 months, you would have 4 that are extreme, something that you have not seen in the past, and only 1 that would be normal. So we see clearly, basically, we have a global crisis affecting all of the world, but also affecting us all of the time, increasingly with increasing global warming. So we need to consider the risk for this global crisis. It could be disruptions of supply chain, of the global economic impacts, also in risk of conflicts, also if all those regions are under threat at the same time. So the other aspects we looked at also in the last IPCC report, and there is more literature on this, which will be assessed in the 7th cycle. For instance, the question of multiple change in climate extremes, when you have At the same time, different extremes acting in different locations, or at the same location, different extremes acting at the same time. So, for instance, if you have heat waves and droughts at the same time, this means more risk of fires. Or you also have the risk of compound flooding in coastal areas, because at the same time, you have an increase in heavy precipitation, an increase in sea level. So those two effects together lead to even more risk of flooding. And then you can have concurrent extremes in multiple locations. For instance, affecting breadbasket regions, we see that with increasing global warming, there is more risk that all the different agricultural areas will be affected by climate extremes at the same time. So this would threaten the global supply of food. Okay. So I want to come to the solution, but before coming to the solution, there is a diagnosis. Where do we stand? We have seen that it makes a huge difference if we have, in the future, if we manage to stabilize global warming at 1.5 degrees, maybe 2 degrees, or actually go to a much higher level of global warming. And what you see here is from the last synthetic report from IPCC in 2023. And you see the implemented policies are showing where we stand in terms of emissions. It's more a stabilization of emissions, but we are totally not on track for a trajectory to stabilize global warming at 1.5 degrees, and not even at 2 degrees. So we are totally off track. Even if we take the nationally determined contribution, we will be clearly above 2 degrees. At the moment, we expect global warming of around 3 degrees. So we are not on the right trajectory. So what can we do? The main question first is what is the cause for global warming? The main cause is CO2 emission, and the main cause of CO2 emissions is burning of fossil fuels. That's what you see here. It's evolution of CO2 emission. The main reason is basically burning of coal, petrol, and gas. So 90% of all CO2 emissions come from fossil fuel burning. So sometimes I say, actually, it's kind of easy. The solution is just you stop using fossil fuels and it's solved. Yeah, but it's not that easy maybe to go to this solution. But in the end, you do see that the connection is quite easy to see. So in the end, the climate crisis is an energy crisis. Actually, Chile can play a huge role there because, of course, you have a lot of the solutions for the energy transition. So for reaching net zero CO2 emission and stabilizing global warming at a level close to 1.5 degrees, as close as possible, it's essential to phase out the use of fossil fuel as fast as possible. And for this transition, the expansion of renewables, solar, wind, and hydropower, and the electrification of energy use are crucial. Okay. So I want to finish with some good news because I know it's a bit depressing. And there are some good news, fortunately. That's also from the last IPCC report. It was a Working Group 3 report. And it's showing that there are many solutions that exist. So it's showing what are the possibilities that we have to reduce emission until 2030. And that's just in the energy sector. There is a solution in other sectors. But you see in the energy sector, there is huge potential until 2030, so only in a few years. For instance, for the expansion of wind energy and solar energy. So we have the order of 4 gigatons of CO2 for each one of them. And at the moment, we have 40 gigatons of CO2. So each one of those barrels would represent 10% of the current day CO2 emission. If you put them together, it's 20%. If we were to do this, we would already reduce emissions by 20%. The other good news is the color of the bar. So part of the bar that is in blue means that the cost would be lower than what we spend now. We are actually spending a huge amount of funding on fossil fuels. And in this case, for a large part of this transition, it would end up being cheaper than what we do right now. So there are some good news, fortunately. So the vision for the future, maybe that is here, is what do we want for us, for our kids, for our grandkids? Do we want to go with the world of here on the left or the one on the right? And the picture on the left, this is not the AI generated. These are actually pictures of events that really already happened. But of course, with increasing global warming, such events would happen even much more frequently, or would be even worse. But we can do what we see on the right. There are solutions that exist. And so we could stabilize climate as we know it more or less right now. So I finish with this. It's from a video of the IPCC special report on 1.5 degree global warming. Every action matters, every bit of warming matters, every year matters, and every choice matters. Thanks for the attention.
Thank you very much, Professor Leander, for this very nice overview of the IPCC work and the new results. Now, our last speaker is Ines Cardoni. We're honored to welcome her. She's Vice Chair of IPCC Working Group 1, Professor at the University of Buenos Aires, and Senior Researcher at CONICET's Center for Atmosphere and Ocean Research in Argentina. Dr. Camilloni is one of Latin America's leading atmospheric scientists and has contributed to multiple IPCC assessments, including the special report on 1.5 degrees and the fifth and sixth assessment reports. También entiendo que va a hacer esta presentación en español para hacer el contenido de su presentación. Muchas gracias.
Bueno, buenas tardes, muchas gracias. Para mí es un honor. I'm sorry for my colleagues. Pero hablar sobre el clima de la región, estando en Chile, viniendo de Argentina, me parece que correspondía hablar en nuestro idioma. Así que aunque las diapositivas están en inglés, voy a hablar en español. Y lo que voy a hacer es contarles un poco qué es lo que sabemos hasta ahora de cómo ha estado cambiando el clima, particularmente desde que se publicó el último reporte del IPCC en el 2021, una descripción de cuál es el estado del clima en la región. Y esto, adelante, son las tendencias de la temperatura. Bueno, las tendencias de la temperatura para la región de América Latina y el Caribe, si lo subdividimos en 4 regiones: el Caribe, México, Centroamérica y Sudamérica, para 4 periodos de 30 años, desde comienzos del siglo XX, 1901, hasta el último periodo entre 1991 y 2024. Lo que se puede ver es que claramente hay un aumento significativo en la temperatura en toda la región, con algunas diferencias intrarregionales. Particularmente en el último periodo se destaca México como la región de mayor aumento de temperatura, pero seguro lo que podemos decir es que no solo estamos en una región, si consideramos toda América Latina y el Caribe, que se está calentando, sino que lo está haciendo además de una forma acelerada. Y es una de las cuestiones importantes a tener presente. Y el gráfico que sigue se asemeja al que presentó antes Sonia. Ella lo presenta a nivel global, y esto es lo que se ve también para nuestra región de América Latina y el Caribe, y cómo ese calentamiento se está haciendo cada vez más significativo, cómo estamos cada vez con valores de temperatura que están por encima de los correspondientes al periodo de referencia, que es este periodo que tomamos entre 1961 y 1990. Por lo tanto, ese es otro de los mensajes que también es importante tener presente. Estamos en una región donde el aumento de la temperatura es muy marcado, se está dando en forma acelerada, pero eso significa además que estamos viviendo en los últimos años temperaturas que están significativamente por encima de lo que eran nuestros valores de referencia cuando evaluamos qué es lo que pasa día a día con la temperatura. Y esto es lo que pasó particularmente en el año 2024, el último año que tenemos información completa para la región. Todavía no tenemos el dato del año 2025, y lo que se ve son lo que nosotros llamamos las anomalías de la temperatura, los desvíos respecto de este periodo de referencia, 1961-1990. La región de América Latina y el Caribe estuvo casi 1,5 grados por encima de ese periodo de referencia, y en todos los casos estuvimos por encima del promedio global de aumento de la temperatura. Por lo tanto, es una región que además se está calentando, por lo menos en lo que ocurrió en el año 2024, por encima de lo que pasó con el promedio a nivel mundial. Vamos a ver el mapa completo, lástima, porque lo pasamos a PDF, que lo que muestra son los valores de temperatura, pero tomados en el año 2024, el promedio en las distintas estaciones meteorológicas que tenemos en la región. Una de las cuestiones más distintivas que muestran estos mapas tiene que ver con los vacíos de información, con cómo muchas de nuestra región de América Latina y el Caribe no está siendo observada en la forma en la que hace falta. Por lo tanto, no solo hay vacíos con respecto al conocimiento de la ciencia para comprender algunos procesos, sino que también tenemos vacíos con respecto a las observaciones. Para poder contestar las preguntas que nos impone la ciencia, necesitamos observar. Y en ese sentido es muy importante el lema que usa la Organización Meteorológica Mundial en este año, y que lo hizo público particularmente en el Día Meteorológico Mundial, de la relevancia de observar hoy para significativamente poder implementar las medidas necesarias para proteger el futuro. Si cambiamos de variable y ahora hablamos qué estuvo pasando con la precipitación en nuestra región, estos son también los promedios de temperatura entre el año 2012 y 2022 con respecto al promedio entre 1960 y el 2022. Fíjense que los colores rojos indican todas las regiones donde la precipitación estuvo por debajo de ese promedio, los colores azules, que no abundan, donde la precipitación estuvo por encima del promedio. Y claramente se identifica Chile prácticamente en su totalidad, la Patagonia, Chile y del lado de Argentina, gran parte de Brasil, el nordeste de Brasil, como regiones donde la sequía ha sido muy, muy significativa en el promedio de esos 11 años, entre 2012 y 2022. Si miramos la cantidad de años en los que ocurrieron sequías también en nuestra región, los colores azules indican pocos años con sequía, los colores a medida que avanzamos hacia el rojo, mayor cantidad de años en sequía, de nuevo entre 2012 y 2022. Chile claramente aparece como una de las regiones más distintivas de la región, donde se ha sufrido muchos años con sequía, pero no es la única. Aparecen otras regiones, particularmente en la región en Brasil, ¿sí? En menor medida en otras zonas como Argentina. Otra de las variables que son importantes son aquellas que condicionan la ocurrencia de incendios. Y cuando asociamos los incendios a temperaturas extremadamente altas que se superponen con periodos de sequías, es donde podemos evaluar un índice que nos da una medida de condiciones favorables para la ocurrencia de incendios basada en forzantes, lo que nosotros llamamos forzantes desde el punto de vista meteorológico, ¿sí? Por supuesto que hay otros motivos que pueden generar un incendio que tienen una componente humana, pero si pensamos en condiciones ambientales favorables, tenemos que mirar la temperatura y la precipitación. Lo que muestra estos mapas que ustedes ven acá es el cambio en el número de días extremadamente cálidos o en el número de días secos, cuando hacemos una comparación entre 1971 y el año 2000 y entre 2001 y 2022. Lo que nos muestran esos mapas es en qué medida aumentó la cantidad de días entre el primer periodo y el segundo, en el que tenemos condiciones extremadamente cálidas o condiciones extremadamente secas, donde aparecen, en este caso, los colores marrones, ¿sí? Y se ve que las condiciones muy cálidas aumentaron en toda la región. En este caso muestra particularmente Sudamérica. Las condiciones extremadamente secas también aumentaron significativamente en Sudamérica, y eso significa entonces que aumentó la cantidad de días con condiciones favorables para la ocurrencia de incendios en gran parte del continente. Y esto se ve cuando combinamos, por lo tanto, estos factores, calor excesivo con falta de precipitación o sequías muy, muy abundantes, También podemos hacer una cuenta acerca de la cantidad de días en el año en la que se dan estos procesos compuestos, ¿sí? De exceso de temperatura y sequías. Y ahí aparecen particularmente destacadas 3 regiones donde si uno hace el análisis, no solo comparando el promedio entre 2 periodos, sino la secuencia temporal, se ve una tendencia creciente a la ocurrencia de condiciones favorables para el desarrollo de incendios en estas 3 zonas de Sudamérica. Si vemos que estuvo pasando con otra componente relevante para el sistema climático, que son los glaciares, también en nuestra región, de una evaluación de 5.500 glaciares a lo largo de los Andes, lo que se ve es que desde fines del siglo XIX, en los últimos 25, 26, no, más años, perdón, se perdió un 25% de la cobertura de hielo que hay en esos glaciares. Y particularmente en el año 2024, Venezuela se convirtió en el segundo país del mundo donde desaparecieron los glaciares a partir de que se declaró extinto el glaciar Humboldt. Y otra característica importante de la región es que hasta hace poco el glaciar Perito Moreno en la Patagonia Argentina era considerado como el único glaciar estable en la región, por más que estaba rodeado de otros glaciares que claramente estaban en un proceso de retroceso, y un análisis que fue publicado recientemente, lo que muestra es que lamentablemente el glaciar Perito Moreno también está en un proceso acelerado de retracción. Otra de las cuestiones importantes para nuestra región es que estuvo pasando con el nivel del mar sobre nuestras costas. Y en este caso podemos evaluar distintas regiones en Sudamérica y en América Central y el Caribe, y evaluar en qué medida fue ascendiendo el nivel del mar. Donde ustedes ven los colores rojos en los mapas que están por debajo son las regiones donde el nivel del mar ascendió más, los colores amarillos es donde ascendió, pero relativamente un poco menos. Entonces lo que se ve es que si bien hay un ascenso generalizado en toda la región, hay algunas asimetrías. En general tenemos un mayor ascenso del nivel del mar en las costas estes de nuestras regiones, un menor ascenso del nivel del mar en lo que tiene que ver con las costas de la región del Pacífico. Y ese ascenso del nivel del mar, además, en algunas regiones tiene una magnitud que es mayor que el promedio del nivel del mar cuando se lo considera a nivel global. Ejemplos de ascenso del nivel del mar en 2 ciudades costeras, en Valparaíso y en Buenos Aires. Y lo que tenemos es que en las 2 el nivel del mar ascendió, si consideramos el periodo entre 1993 y 2025. Tengan cuidado cuando vean los gráficos, los ejes verticales están en distinta escala, por eso pareciera que ascendió más en uno que en otro, pero en promedio en Valparaíso el nivel del mar ascendió 5 centímetros, en Buenos Aires ascendió 7 centímetros. De nuevo, si hacemos una comparación para ese mismo periodo que pasó con el nivel del mar en términos globales, por lo menos para estas 2 ciudades estamos un poco por debajo de ese promedio global, que fue de 10 centímetros. Y entonces es un poco el diagnóstico de lo que estuvo pasando en estos últimos años, cómo están las tendencias en algunos de los componentes del sistema climático y en algunas variables. Veamos algunas proyecciones, ¿sí? a futuro, que es algunas de las cuestiones que podemos decir. Y lo que muestra este gráfico son para 3 regiones, de estas regiones que definió el IPCC en su último informe de evaluación. El puntero es el del medio. Para estas 3 regiones, el sudoeste de Sudamérica, el sudeste de Sudamérica y la región del monzón sudamericano, ¿cuál sería el aumento de temperatura proyectado respecto del periodo preindustrial si alcanzamos estos distintos umbrales de calentamiento global? Lo que uno ve es que para estas dos regiones, el sudoeste de Sudamérica, el sudeste de Sudamérica, si el mundo se calienta 1,5 grados, estaremos con un incremento de temperatura levemente por debajo de ese promedio, y lo mismo si el mundo se calienta 2, 3 o 4 grados. Pero fíjense que no es lo mismo lo que pasa en todo el continente, en la región del monzón sudamericano. En estas regiones estaríamos con incrementos de temperatura por encima del promedio global, y en algunos casos, fíjense que es bastante significativo, 5 grados cuando el mundo se calentaría 4 grados centígrados. Si vemos qué pasaría con la precipitación, de nuevo, para estas mismas tres regiones, fíjense que tanto en la región del sudoeste de Sudamérica tendríamos una tendencia a la reducción de la precipitación, pasaría lo mismo en la región del monzón sudamericano, mientras que las proyecciones lo que muestran es una leve tendencia al aumento de la precipitación en el sudeste de Sudamérica. Estas proyecciones que tenemos a futuro de alguna forma se ajustan también con lo que estuvimos observando en las últimas décadas, ¿sí? La precipitación en el sudeste de Sudamérica es una de las regiones que muestran la mayor tendencia al aumento de la lluvia. Las proyecciones muestran que ese aumento de precipitación continuaría, ¿sí? Algo que en la carga del cambio climático, cuando hablamos de agua, de alguna forma se dice que los ricos seguirían siendo ricos en términos de disponibilidad de agua, mientras que los pobres tenderían a ser cada vez más pobres. Hicimos también proyecciones en términos de un índice vinculado con la ocurrencia de incendios, y si ese índice lo ponemos en una escala que va desde un riesgo bajo hasta riesgos que van creciendo a medida que nos acercamos en colores rojos, y la información está presentada en términos de estas columnas, donde por debajo lo que tenemos es el nivel de referencia y qué pasaría con el riesgo si aumenta el promedio de la temperatura global respecto del periodo preindustrial. La información está a nivel global, derivada de modelos climáticos de alta resolución, que son los que mostraron mejor habilidad para calcular estos índices. No voy a entrar en detalle para toda la región, pero fíjense que si nos concentramos en el sudoeste de Sudamérica, en esta región, es donde claramente a medida que aumenta la temperatura, pasamos a una situación donde el riesgo aumenta. Y no es lo mismo en todas las regiones, sino particularmente en esta zona de Sudamérica, donde se nota ese incremento con respecto al riesgo. Otras proyecciones vinculadas a qué pasaría con el nivel del mar. En este caso, para Callao, el puerto del Callao en Perú, o en Belice, en América Central. En los dos casos, las proyecciones están hechas entre el año 2020 y el 2050 para un escenario de emisiones intermedias. En ambos casos lo que tenemos son proyecciones de aumento del nivel del mar, pero fíjense que las proyecciones lo que muestran en los dos casos son incrementos más significativos que los que se observaron hasta ahora. Con lo que esto nos está diciendo una aceleración con respecto al el ascenso del nivel del mar, por lo menos en estas dos regiones. Por lo tanto, algunos mensajes claves que son importantes tener presentes con respecto a qué está sucediendo, qué estuvo sucediendo con el clima en los últimos años en Argentina, en la región, tiene que ver, perdón, nos incluyen los argentinos, pero abarca más. Es este aumento sostenido y acelerado en la temperatura, y eso se da en todas las regiones. Tenemos regiones con una tendencia a la reducción significativa en la precipitación, condiciones más favorables para la ocurrencia de incendios, por lo menos vinculados a temperaturas muy altas y déficit de precipitación. El nivel del mar está ascendiendo en nuestras costas, en algunas regiones en forma de mayor magnitud que en el promedio global. Tenemos un retroceso generalizado de los glaciares, que ahora ya incluye el único glaciar que pensamos que estaba estabilizado, que era el glaciar Perito Moreno.
de nuevo, en nuestra región, ahora tenemos el segundo país del mundo que ha perdido, después de Eslovenia, que ha perdido totalmente los glaciares. Esto es todo y gracias.
Muchas gracias, Camiloni, por esta charla muy informativa. So for the next part of this seminar, we will now move to the panel discussion. Now, in addition to our 4 speakers, I'm very happy to announce that we will be joined by Dr. Ladislaus Changa, Vice Chair of the Intergovernmental Panel on Climate Change. Dr. Changa is a Tanzanian climate scientist and meteorologist with decades of experience working at the interface climate research, climate services, and policy. He has contributed to national and regional climate assessments to the development of climate strategies in Africa and has been actively involved in the IPCC process over several cycles. The panel discussion will be moderated by Camila Fernandez, who has already given the first welcome speech. Now, if I could please ask our 5 panel members to step in front here.
Please. So thank you so much, everyone, for your very impressive and informative talks. I would like to open the room for discussion and questions from our public. So please just raise your hand and we can take it from here. Yes, we have the lady and then...
Inés, hola Inés. Voy a hacer la pregunta en español, pero si quieren responder en inglés. Dice en las proyecciones que hicieron. Hola. Ya, bueno, en la charla que viste, habla que lamentablemente hay pocos datos meteorológicos de las zonas de Sudamérica o Latinoamérica en general. Por lo tanto, es difícil hacer proyecciones realistas, podríamos decir. Entonces, lo que a mí me saltó la duda de cuál sería la causa de que no hay este tipo de información que es tan relevante. ¿Son causas políticas? ¿Son causas de otro estilo, más física? Me gustaría conocer la respuesta. Gracias.
Gracias. Sí, lo que quise decir es que hay muchas regiones que no están siendo observadas con la densidad de estaciones meteorológicas que hace falta. No quiere decir que toda la región esté subobservada, sino que tenemos algunas regiones donde la información no es suficiente. Eso no limita la capacidad de hacer proyecciones acerca de cómo va a comportarse el clima en el futuro. Pero lo que sí es importante es, primero, que no se reduzca la cantidad de estaciones que tenemos, que esa red de observaciones se sostenga y que se mejore para tener más observaciones en lugares donde no las tenemos. Hay información que puede ser reemplazada a través de información satelital. Tenemos sensores remotos que nos aportan información, pero la información de las estaciones meteorológicas de superficie cumplen un rol esencial. Y es importante que esa red mejore en muchos de los países de nuestra región, particularmente, puedo decirlo en el caso de Argentina, tenemos muchas regiones que están subobservadas. Pero ese fue el mensaje que dice.
Thank you. So regarding the gaps in data, all over Latin America and the Caribbean, there's a good coverage, but evidently there's some areas that need to be covered. And I would like to follow up with a little bit of a question before giving you the floor. So where would you want to see a coupling between land and, for instance, ocean observation? Because we can observe in a more limited scale in the ocean. There is more need for data. But what areas would you like to be better covered, by this land-ocean interaction?
In our region, we can improve observations both in the Atlantic, both in the Pacific. We have satellite information that is absolutely relevant, but we need also in situ information, voice, for example, and we already have some. It's important, in particular in the Pacific, in the Equatorial Pacific, where the development of an ENSO event, it's absolutely relevant for the climate of our region. But we need to have this network of observation. But it's not only important to make observations randomly. We need to have sustained information along the time. When we talk about climate change, we need long series of observations. So.
I could add one point on droughts. Also, a variable that is not always very well measured is soil moisture, and so that's would be also important actually in South America to have more information on this, especially for ecosystems.
Okay, thank you very much.
Yeah, thank you very much. Just to complement on the issue of observation, there are several initiatives that are going on, and I would like to flag one, which is through WMO, Systematic Observation Financing Facilities. So if we can try to follow that, I think it can contribute towards strengthening observation, and which is critical, definitely, for ensuring that our reports and our understanding about the climate system is much enhanced.
Thank you so much. So you had a question.
Thanks for the great presentations. My name is Cristian Martinez Villalobos. I'm a climate scientist from Chile. I was just wondering why no chapter on climate model evaluation. Seems to me pretty essential.
This is such a good question. Actually, this question we asked that at the scoping meeting. That was one of our questions to the experts. How about a chapter on model evaluation? And we discussed that at length. And we felt that a chapter that would be evaluating models, that would be disconnected from the different questions that we are asking all around the report, would be a standalone and maybe not answer correctly everything. We have projections for which we need specific types of evaluation. We also have attribute.
Oh, sorry.
I think it's we have attribution of extremes for which we need specific also model attribution. We have a chapter on processes. We have a chapter on specific on basic processes, and the evaluation of model for basic processes is a different type of evaluation. We have different. Maybe it's me. Yeah. So we have the different components. So we felt that it was better use of model evaluation to have it where it is needed in the report. At the moment where we evaluate the lines of evidence to make a specific statement, projection, attribution, anything, it would be better placed to have that there, rather than a single chapter on model evaluations.
Thank you. At this moment, for our assessment report, in the chapter 1,
we will have a model evaluation session. And for the very high level introduction. And in each chapter, if they need, and they will have a model intercomparison, model evaluation session, just distributed from the different chapter.
Thank you. Alex?
What's
Yeah. I think it worked.
Hello guys, welcome to Chile. I am Alex Roboy. I'm CLA Observer 1 and working with 3. Just I'd like to ask something specifically about the use of the AI. Because right now you have competitors and another kind of, Google and other big companies, private companies indeed. But for one side, we are talking about the monetary system and trying to get more data. But for another side, the mathematicians and the complex scientists are looking for simplify maybe the modeling of the. So we are going to deal, and this is not my hat of what you see, the AI introduction, because right now the government thinks that maybe it's easier, maybe we can replace all scientists by just using models. How we can going to deal with the use of the artificial intelligence and in the climate modeling and forecasting weather and so on, because in my opinion is a big issue and beyond of the monetary station. Thank you.
Good question. Take it.
Who would like to?
It's really a chance and also the challenges for the model development processes. For example, and if we want to have a prediction exceeded nine days, if we want to get a precise prediction in the past, and there's no way, and you need to have a parameterization. So there's so many rules, and they just focusing on the different parameterization, but that will bring the uncertainty. So if you just try to long-term precise prediction, and it's hard. We just can't just pinpoint the irregular atmospheric circulation, but AI so give us a chance. And this is a really competition, traditional and AI. And maybe the AI can help to increase the projection of our climate model and weather model a lot.
Yeah.
I'm not that
Yeah. Okay. So maybe I think we have big question marks for the modeling side at this moment. There's a lot of research on that. One big one is that human activities have put the climate system in a completely unprecedented state. And we do not have precedents for what we are observing now in the data. So can we rely, and how can we assess that models will be models uniquely data-driven, can project something? How can we be sure that these models can capture all the processes, the feedbacks, and all the complexity of the Earth system in a completely different state than from the data is a very open question at the moment. So that's my first. I would have more, but I will give the floor to my colleagues.
Actually, I wanted to make more or less the same point. So I think the main problem with AI is that you need training data, and so it's well established. So for instance, now we speak a lot of AI in the context of weather research because they are pretty good AI-based weather models, but they are trained on current conditions. And there have been several studies showing as long as as soon as you go into extrapolation, I mean, AI is actually not really able to extrapolate beyond its training data. So, I mean, of course, you can train some AI models based on existing climate models, but then you will still need the climate models which have the physical understanding of the system to be able to extrapolate to even more extreme conditions. So I would say, yeah, AI, I see this more as a tool, but I think we shouldn't overestimate what it can do.
Thank you so much. More questions? Kristen.
Thank you so much for your presentation. I am Cristian Hernandez from Concepción, from Universidad San Sebastián. I am evolutionary ecology. This is come from my question. All this is for the final idea is to preserve our life, the life in the earth. But how your model intermingle with the variable biodiversity, with the variable life, because life is not a static thing. It's not only the dependent variable. It's part of the equation. And if we don't consider how this life change and how this life intermingle with the climatic model, it's impossible to try to preserve life. This is my question. And also, I think from my expertise, it's very important to start to consider the past evidence of change in the climate and how this affect our biodiversity in the past, because we have a big book of experience in the past, but we don't use it today.
Yeah, it's an excellent point, and the answer to your first question is the models are not that good at representing vegetation dynamics and biological processes, and it's actually a big issue. So, for instance, in climate models, typically the trees are not going to die, and that's a big problem for instance, some of the processes I was mentioning, the drought feedbacks on the carbon cycle. So we have evidence from observation which shows very clearly. So if you compare satellite data with CO2 concentration, we see that in those years which are basically drier, we have an increase in CO2 in the atmosphere. So it's very strongly correlated. So it suggests that vegetation either is dying, a fire, or it's more less efficient at taking up CO2. But the models don't have this correlation, or I'm underestimating it. So no, definitely I would not totally, not even very much trust the models for this aspect. It's difficult, of course, because if you want to represent this in a very realistic fashion, I mean, we need to have much better models. I think the evidence from observation certainly show that those ecosystems can be very sensitive. I mean, one aspect that is now investigated also in AR7, and we have a chapter on tipping points. So some of this would be addressed, but I think we have to realize the models we have, they are limited in this aspect.
Maybe also where there is something that is missing is, we are projecting for the future scenarios. However, those scenarios are quite linear, with respect to what we are to the current trends. So they continue. We are making assumptions. But if we have big disruptions, even the scenarios themselves are affected by that, because the economy would go to crisis and things like that, and also the carbon cycle. So we don't model very well the feedback from the extremes and from the disturbances to the economy world and to the biodiversity and also social life world. So this is something that we definitely need to progress on.
Yes.
At this moment, we already have some progress. For example, the Earth's model uncoupled with the IAM model. That IAM model is just can tell something about the social economic change.
Yes.
And also your expectation for the model to do everything. And but they can tell for example, if we have a plausible emission scenario, and we will in this cycle, and the scientific community and also decision maker ask us, can you provide a more feasible climate warming level? So during some period, and you will see the global mean temperature will reach the peak and then a little bit stabilize and then go down. This is highly related with the human being, the human health and the living standard and so on. We can infer from this and to see even the tree or some biogeochemical fear or something.
Thank you. Another question, please. Thank you. I'm Maria Teresa Alarcón from the Ministry of Public Infrastructure. I kind of have, I think we all agree that the science world is agreeing in this climate crisis, but also the political world, the normal kind of normal world, they're not agreeing on that. They are still in climate change and trying to kind of see that, okay, maybe it's true. So there is this big problem. Sonia, I thank you so much for your presentation. I think it's really important that you showed the focus on these extreme impacts, and also that the extreme impacts are kind of a domino effect. So this is like so urgent, especially in public infrastructure that is basic for human survival. So how does this new focus, this new crisis kind of impact our way of seeing things is expressed in the summary for policymakers, that we know that is kind of our translation, so that we can have more public policy to face this?
Thank you very much. So you have to wait one more year. There will be our first report will be very relevant for your question on climate change in cities, because there will be, I cannot unveil today the material, but there is it's in the agreed outline, so it's public. So there is a focus on those type of events, and precisely such a report is very interesting because all the working groups are integrated together, so we can go from the cause, the physical cause of the cascading impacts and things like, all the way to the socioeconomics. In this report, in working group 1, we cannot go to the socioeconomic because that's not our mandate. So the cities report, cities are where most people live now. So we'll tell a lot about that. And also in working group 1 report, there will be a lot of new information on what we call compound events. It's an emerging field. It has emerged. Actually, there's now a lot of literature, much more literature than in AR6 in the previous cycle, and we really think that there will be very high level messages, but you will have to wait 2 years now for this one. Yeah, that's just one. Sorry, you go first. Yeah. Okay, thank you very much, Maria, for the important question. So I just wanted to compliment by saying that that's why we are here, and this is a collective effort need to be done by every one of us in terms of unpacking the finding from IPCC and escalating it to the policymakers. Therefore, we would like to submit that this group here have a commitment to ensure that once the report is out, if we can be able to prepare some kind of policy brief, unpacking some of the key finding narrative, that we can be able to engage with our policymakers. We've been doing this as IPCC, for example, we're engaging with the youth in various fora for the purpose of ensuring that
we strengthen the dissemination and the communication of our finding to the last mile and to the people who matter the most. And the young people, I think we understand they're energetic and they can be able to do this job very well. So in every COP meeting, we have a very comprehensive interaction with the young people, but in other events as well. So I submit that we also consider once the report is out to engage as much as possible, but not only that, but we submit as well that once the draft FS or the draft is out, we should also commit towards reviewing it as much as we can from this end. This will add more value in terms of some strengthening the report itself.
Yeah, I think this is a very good question, and I guess behind is the public and also the decision maker maybe don't believe the climate crisis is so dramatic, something like this. This is exactly our working group, especially the working group 1 report will answer this question. We want to have a balancing, transparent scientific assessment. For example, if we can get a more in line with the feasibility of plausible future emission, and we will at this moment we can tell till the 2050s, and the warming still increasing. But during the increasing, that will associate with the increase extreme. But after that, the situation just a little bit changed. And this kind of the information is really important for the decision maker. Yes, the warming, the climate warming will have a big impact to the society associated with extreme, definitely. But we will tell the decision maker which period, after which time, and the situation will change toward extent, and how much you need to pay for adaptation, and to the sea level prevention or something. This is really important, and it's also our job to balancing the climate processes and also the scientific rigorous need, and we try to give a more plausible future warming level and associated climate impact.
Maybe Robert and then Sonia and then Robert. Excellent question. I mean, it leads to a lot of answers. But I think, I mean, obviously we don't know yet what will be our conclusion, but the conclusion I've shown is already based on the past report, and it's well established that those extreme events are becoming more frequent, and we can attribute them. We know also that, again, people are dying of those consequences. Of course, some regions, may have more or less of some changes, but I mean, we cannot anticipate all of what the conclusions will be, but I do expect we might be surprised that some of the conclusions will be quite dramatic because we have a chapter on tipping points. So, I mean, I can speak of my own experience. I was an author on the 1.5 degree global warming, which came out in 2018. And before I was actually a bit less concerned. And when I saw all the evidence, we actually were not exactly sure how strong the evidence would be. But once we saw it, and we saw it's very robust, that even half a degree
makes a huge difference for changing climate extremes, for impacts, actually also for biodiversity, for the coral reefs. Already now they are under very big threat, and so at 1.5 degree we have about 70 to 90% that are disappearing. At 2 degrees it would be 99%. If you go above 2 degrees, you have to imagine what the consequences would be. So I do expect we are going to have strong evidence. Of course, maybe some others we find maybe a bit less change, but in the end, I think the latest evidence rather shows that the warming has been rather faster than what we had in the past.
Yeah. Just to give a number, I think there was a Lancet report very lately saying that in Europe heat has induced in 2024 more than 60,000 deaths due to heat, due to climate change heat. So that's the extent. Heat is a silent killer. The heat waves. It's not catastrophic in the sense that it doesn't break bridges, it doesn't break infrastructure, but it kills a number of people, and it puts a number of people at risk of dying because they also have other problems, and it accumulates all the problems, so it creates a lot of trouble.
I think that is a very important point, because I do remember the first heat wave that hit Europe in 2003, and it killed 1,500 people, mostly elderly people.
Yeah.
But in nowadays, in the context that we are living now, that wouldn't necessarily make the news, because the numbers are much higher and the frequency is much higher, and we are talking about compound events and compound responses from society as well. We have time for a final question at the back, and if we can approach, and then we will wrap up.
Thank you very much for giving me the floor. Thank you very much for this excellent speaker presentation. The background, I do RSO negotiations, so that's research and systematic observation negotiations under the IPCC. So the question is going to be a bit related to things that might be relevant to be in the report, because parties will discuss over those in that topic. So trying to be very quickly, the first one, there is an issue with the confidence levels on different regions. Probably for parties, at the moment discussing that, there is a question why there is different confidence levels. Is the lack of capacity? There may be other reasons. Having not only the gaps, but the reason for the gap might be relevant for discussions on the UNFCCC regarding capacity building for better research in the future related to those gaps. The second is about the projections, that very correctly, yes, projections are not socioeconomically neutral, depends on a future of socioeconomic system that will be in the future that will enable increase emissions or reduce emissions. One of the big, I was there when the last time we negotiated the SPM reception under the UNFCCC, and one of the big issues in that negotiation, I don't remember that much, was actually about the underlying scenarios. So IAMs, this is a criticism for IAMs, usually tend to go lower cost, but if you go lower cost, that means a lot of the mitigation has to happen in developing country parties. And of course, that doesn't please a lot of developing country parties. So this is to what extent a diversity of different scenarios with underlying socioeconomic conditions for the future will be reflected in terms of the projection. That will be very interesting in help to inform probably not only climate-related policy, but also how this intertwines with other policies that inform those futures. Irrigation of poverty at the end is essential part of the Paris Agreement. And the final one, and this is probably one of the big question, is to what extent Working Group 1 will help answer attributions to countries. Loss and damage is becoming a bigger question after the ICE consultation happened last year. So this is definitely one of the things that parties very much will be discussing, and to what extent who is responsible to what part of the total damage.
Thank you. We can answer some of the questions.
Yes.
make a selection.
Yeah, no, I can give an answer to the first and third question. So about the difference in confidence in the observed changes. So there are different reasons for that. So for instance, when we have low confidence, and we did distinguish this in the figure. So you can see the two cases. There can be either low confidence because there is data, but there is low agreement in the data. So for instance, you have different observations that are showing different signals, or depending on sub-regions, you have different signals. So that would be low confidence because the climate signal is not very clear. Or you can have low confidence because you have a lack of observations or lack of studies. So basically you don't know absolutely. So we did distinguish this in the confidence statements on basically the change in climate extremes, and it's indicated there. Then about the last question, it was the loss and damage by countries. Yes, so it's something I gave a presentation earlier today at the University of Chile, and I presented. I had more time. I presented a recent study we published. We actually showed the attribution of collective attribution of heat wave to single emitters. So, for instance, to the producers of fossil fuels. So we are actually at a situation now where you can actually look at the footprint of single companies. You can look at the footprint of single countries, and you can actually say to which extent this footprint made a difference for some of the heat waves that happened. So we are starting to have data on this. I don't know if it will be in the report, the authors have to decide, but there is literature on that.
Yeah. So I added, just follow the Sonia's answer. We can do the loss and damage attribution, and even this is not our working group one business, but the mitigation of the climate change and also the whole climate change society, they're not doing things like this way. This just we face the problem, climate warming, but we encourage the global, the whole country, and to do something. For your second question is, if you try to climate mitigation, climate adaptation, that will cost some money and will influence the social economy growth, because in the past almost 300 years, so they just established burning the fossil fuel and to support the social economy change. But so far, as have a region, have a country, have a city, they can take some climate action and also to increase their social economy, their GDP. For example, China, they have already have this kind of the example. So that means you don't need to pay a lot of, and you just do gradually, and you can have a new way, new pathway, and using non-fossil fuel to support the social economy growth. So this is a global source. Country is really like to see the situation.
Robert, for closing up.
Yes, just to on this, but our colleagues from Working Group 3 may also have a better answer on that. The equity, the question of equity, also in the mitigation, realm is what was maybe not very prominent in the past cycle. I'm sure that it will be prominent in this cycle. It has been brought forward. Also, one thing that we cannot assess in very detail is the cost also of not mitigating, and
we have to, there's a lot of complexity in this question, and often we see the cost of mitigation just the cost of investment into renewables or whatever, which is, by the way, cheaper now than fossil fuels. This cost is there's another side of this cost, which is what if we don't do it? There is also a cost. So this part will likely be also addressed, but I'm not the best placed to say that. But in any case, we have to do something.
Thank you so much. Ladislav, you want to close up?
I thought I should say something about express our deep appreciation for your work and contribution from the scientists and experts from Chile. I was just going through the IPCC website, and I found that in this cycle we have 20 authors and experts from Chile, which is 4, 3, 2, and then we have 6, 2, 3. Now I'll explain. We have 4 authors in working group 1, and 3 authors in working group 2, and we have Alex in working group 3 and Felipe, but also in short-lived methodology report on short-lived climate forces, we have 6 authors, and also in methodology report on carbon dioxide removal technology, carbon capture, utilization, and storage, we have 2. And then on special report on climate change, special report on climate change and cities, we have 3 authors. So this is remarkable, and we can only appreciate and express our deep thanks for your contribution. And that's why it will be good for this group to support that narrative by putting our commitment to participate in the review process. Thank you very much.
Thank you very much. And we are closing our panel. This has been tremendously enlightening and inspiring. And this is one of the objectives of this very meeting. Get the scientists in Chile, Latin America, and the Caribbean involved in IPCC, but also involved in their own countries' Council for Climate Change. They are networked along Latin America and the Caribbean, and there are processes of selection for scientists to participate in all these instances. This is all voluntary, and as it is voluntary, it is also our duty to pass on the information and get the next generation involved. I thank you very much for your super answers.
We forgot to mention our bureau member, Laura. She's here, and I think if you can just stand up and maybe just
Yes.
Laura Gallardo, thank you so much for coming. Fabrice, the floor is yours.
Thank you very much. Thank you very much, panel speakers. IPCC Vice Chair Ladislav Changa, IPCC Working Group 1 Co-Chairs Xiaoye Zhang and Robert Baudard, IPCC Working Group 1 Vice Chairs, did I say Co-Chairs or Vice Chairs? Co-Chairs Xiaoye Yang and Robert Baudard, and IPCC Vice Chair Working Group 1 Ines Camilleri and Sonia Seminario. Thank you very much. Now, to give the closing remarks, please let me introduce Sandra Cortes. Dr. Sandra Cortes is president of Chile's Climate Change Scientific Advisory Committee, professor at the Pontificia Universidad Católica de Chile, and a public health specialist whose work focuses on environmental and occupational epidemiology and the health impacts of climate change. Please, Dr. Cortes.
Muchas gracias, Fabrice. Sorry. Thank you for all the presentations. I as the chair of the Scientific Committee on Climate Change, I would like to thank all the participants joining us for this seminar. My special thanks to these distinguished IPCC researchers who are here with us after the extensive working sessions during the other meetings in the working group 1 in Santiago in this moment. Each of our speakers has a distinguished career defined by their commitment to generating the best available evidence of their respective field, and through their active involvement in various collaborative initiatives within the IPCC. Their presentations clearly illustrated the accelerated change in our planet is facing. Today is Earth Day, and we have focused on sharing what we already know about the prevision of extreme weather events from a global scale down to our own continent, highlighting the deep interconnections between hydrological, atmospheric, and soil change. I want to take this opportunity to recognize their contributions to the national communication of this work and their strong leadership at the international level. From Chile, a country defined by this long coastline, glacier in this mountain range, and densely populated cities exposed to air pollution, we deeply appreciate your visit. As witness to accelerate change happening in our country, every member of this scientific committee is committed to advancing research across all diverse disciplines, from the C4, oceans, glaciers, circular economy, biodiversity, health, and well-being, but also in mitigation and adaptation for our ecosystem and diversity productive system. As C4, we are committed to elevating climate science, promoting and disseminating the scientific evidence generated in our country, and fostering the sectoral collaboration needed to ensure that our NTC and our adaptation and mitigation plans are effective and based on the best evidence available. To support this, we rely on our framework role in climate change. We give its life and institutional banking to this advisory committee. In this context, our experience is available to other Latin American countries as we face similar challenges and strengths. You can count on us. Finally, I want to emphasize that we don't not this work alone. More than 200 researchers from across the country have made this collaborative effort possible, embracing the diversity of territory and the contribution of various disciplines. To everyone who was able to join us today, thank you. Thank you for each of one. We hope to have news soon about the joint work focused in prepared Nexus reports, aligned with the IPCC recommendations in the last presentation since 2025. I'd also like to extend my deepest gratitude to the University of Concepcion for the partnership and logistic support. Many thanks also to Hernan Lopez, head of the Climate Change Division at the Ministry of Environment, and also to Fabrice Lambert. Thank you so much to make all our efforts with extensive power. Many thanks to the Ministry of Science and especially to our technical secretary. Please, thank you so much for their support and creativity despite limited resources. And thank you to IPCC, its TCU staff, who shared with their free time today to make this seminar possible. Today, here in Santiago de Chile, we have celebrated Earth Day together. Thank you. Yeah, I feel. Oh, together. Thank you so much. Come on.